we are working and we bring in, the first thing is, right, the very first thing is going to be, our root is going to point at this first node, and let's say we get a $49.99 in here, right? Or let me make it $50 because I can't write all these digits with my left hand. Okay, so the first one, 50. Of course, you know, there's other data, right? There's the sidecar data. I'm not talking about that right now, right? But actually, maybe I do need to talk about that. So let's say that this is now position 0, right? So this is a price of $50 and this is item 0, okay? Then later I get another one that's $40, so it's going to go to the left. So this one has $40 and maybe it's position 3, okay? Now I get another one that's $50. Where's it going to go? Based on our binary search tree understanding, where's this one going to end up?
To the left of 40.
Right.
To the right of 40, right?
Yeah.
Because it's bigger than 40, so now it's going to be down here. Do you see that that is not really desirable? Because now if somebody says, I want to know whether there's a 50 or go gather all the 50s or whatever it is, do you see that what I'm going to have is a bunch of 50s that are scattered all over this thing? Is that really necessary? Is it completely necessary to do that? Let me draw a little more while I'm here. Let's say we have one that's $60, right? So that one's going to go over here. So the question is, do we want to try to make this work? Right? This is number 5, position number 5, right? Is that going to be something that we can deal with where we have these things scattered all over the place, or can we come up with something else? What would we like? I mean, it's our data structure, right? What is it that might be ideal here? What would we imagine might be a different way, rather than having a bunch of nodes that say 50 all over the place and having to either collect them or do whatever, or just worry about the fact that they're scattered like that?
I don't know, like stack them somehow.
Yeah. Yeah. What could we do with that? What's the idea? Who is that? Was that Torin said that?
Yeah, that's me.
Yeah. Ben, what are you thinking?
I'm thinking if we can do like a check for contains that value already, we can do some sort of stacking thing.
Yeah. Okay. Henry, what are you thinking?
I was thinking store the left for if you had a 40 duplicate, store the left subtree in the 10th variable and then insert it and then attach the subtree to the end of the duplicate so that they're all next to each other.
You could, and that would take some fairly fancy coding, right? Because you'd literally have to reorganize some of those trees and change the parents. That could work, but that's going to take some real engineering, right? But what about this idea of stacking? Right? Can we add all the indices? Right. Okay. So Michael, what's your thought here? Ideally, where would we really like the 50 to go? Right? I think, Michael, you're probably getting the same idea. If we get another 50, first thing we need to know is it's not going to have the same index, right? It's not going to have the same position data. But what could we do here that would be in the spirit of what we're doing, but would save ourselves that time? What about this? Why can't, well, go ahead. Why can't I just put it here? Why can't I just put it here? It's going to have a different number, right? I can't draw it that small. It's going to have a different number. Why can't I just put it here?
But you don't have a variable to point it towards.
Why not?
Make a middle variable.
It's your data structure. Make a reference, right? Why don't we have a left, right, and same, or left, right, and dupe, right?
But only have 2, you said, at maximum 2 nodes.
I'm saying in a traditional binary search tree, we only have 2, but this is ours. We're not stuck on whatever has to be. We can make whatever we want. So why don't we just say, look, if we got one that's a dupe, it just goes down. We have a left and a right and a dupe, or a same chain, right? But it gets better, right? It gets better. Do I actually need to store the 50 again?
Right, that's what I was thinking, is that if you ask for 50, then it would just return multiple indices.
That's right. So I don't even need to store the 50 again, which is kind of amazing. What I really need to store here is just the number, right? Just the position. And then I need to have a reference. And if I have another one come in later, maybe this is number 11, right? Oops, I'm not drawing very well, but you get the idea, right? Do you see what's interesting here? These could actually be simplified node structures. Rather than having, these nodes right here are going to have key, value, left, right, and same, right? They're going to have 5 pieces of data, but these nodes don't have to have that. They really just have to have the position data. They don't need to repeat this because you can get that from here. Right, when you're walking, right, when you're walking through this tree, you're going to get to this 50, and you know that everything that's in its same or dupe chain, it's just like a little linked list, right? All of those are 50s. So you don't have to keep repeating the number 50 again and again and again. All you need to know is what the position of each one of those are, and you need to have a pointer to the next one. So your node structure all of a sudden is collapsed and made a lot simpler.
So it's a simplified node with, that's just a duplicate node with index?
That's right.
Okay.
That way you don't spend the memory for the extra left and right, because you're never going to use the left and rights anyway on those, right? We would never put in anything in the left or right, so why have it? And then we don't even need the key, so why have the key, right? So let's start talking about specifically how that starts to turn into the scenario that